Hello everyone, hope you are learning assembly language programming in 8085. Till now you have seen data transfer instructions, arithmetic instructions, logical instructions and branching jump instruction. Okay, on the basis of these instructions, today I will implement some assembly language programs and I will tell you how to implement a loop and how to implement an array in 8085 microprocessor. Suppose you have to determine largest number in an array of n number. Suppose this is your assembly language program which determines largest number in an array of n number. Suppose total number of elements, or you can say value of count, is available in 2050 memory location. Suppose there are 4 elements. Okay, this 4 is nothing, this is value of C. Okay, this is value of count. Countable means total number of elements are 4, and storing of elements are available from 2051 memory location. Means first number, suppose it is 45, suppose second number 65, suppose this is F2, suppose this is F2 and this is 77. Now you have to determine largest number among 45, 65, F2 and 77. Now what is the procedure? How will you determine? Okay, how will you determine largest number? What I will do? This is the value of count. Suppose I am using for this, I am using this C register. Okay, I am using C register for counter, and because you know to compare two number, one data must be available in accumulator, so I will move contents of 2051 memory location into A, as you have already seen in case of larger of two number. Then I will compare this contents of A, means 45 with 65. Okay, 45 and 65, because 45 is smaller and 65 is larger, so I will move contents of 2052 into A. Now value of A is 65. Now I will compare this 65, means contents of A with 2053, means next memory, which is F2. F2 is larger, so now contents of A will be F2. Now again I will compare F2 with 2054 memory location contents, that is 77, and F2 minus 77, so F2 is larger. Okay, so answer will be F2, and suppose you have to store in 3050 memory location. The concept is very simple. First I will move contents of first memory location 2051 into A. Now I will compare with next memory. Because I am using array here, what I will do, I will use indirect memory instead of direct memory. Okay, and how many times I am comparing? I am comparing only 3 times. Elements are 4, but I am comparing this with this, this with this, this with this, means only 3 times. So this value of C will be 4 minus 1, means we will apply loop only 3 times. And how you will implement any loop? For this, what you will do to implement any loop? Okay, suppose MVIB, or you can say MBSC 03. Okay, what you will do? You know you will decrement C every time, and now you will check value of zero flag. Okay, if zero flag is set, it means J and Z you will use. J and Z, suppose loop 1. Okay, loop 1. This is loop 1. What I am doing, initially value is 3, then DCR says C is 2, J and Z loop 1. Now zero flag is reset, so it will jump to this memory location loop 1. Loop 1 is nothing, it is memory location. Now again value of C will be 1. Again it will jump here. Then again DCR C value will be 0 0. Now zero flag will be set. Now it will terminate from here. It will go to next step. Suppose it is ST. Okay. In this way you can implement any loop. You will use J and Z loop 1 DCR C. Whenever value of zero flag will be set, or you can say value of C will be 0, it will terminate from the loop. In this way you can implement any loop. Now I will implement this program. Okay, first memory is 2050, so use LXIH 2050. Okay, means first memory location is what? 2050. Now what you need to do, you will move this contains into where? C register, C comma M. It means now M is 2050 and contains of 2050 is transferred into C. C means 4, but we are comparing only 3 times, so I will decrement C by 1. DCR what? C. It means C is 3. Only 3 times I am comparing. Now I need memory location 2051. Now what you will do? Increment that memory location, and you know it is done by INX H instruction. INX H. It means M is 2051. Now what I am doing? Now I am transferring the contents of 2051 into accumulator, into A. So use move A comma M. Okay. Then why I am doing this? Because I know to compare two number, one operand must be accumulated. So I am doing this. Now I want memory 2052, means I want 2 point next memory 2052. Again use INX H. Okay, INX H. Now compare this and this. Now you know by compare M instruction, CMPM, you can perform comparison of two number. Compare M. I am comparing 45 with 65. If contents of A is already larger than this, then you do not need to do anything. But if contents of A is smaller than this, you need to transfer contents of this M into A. Okay, so I will use what? J and C. J and C loop 1. This is a label. Okay, later on we will see where it will come. If carry flag is reset, then it will jump to loop 1. If carry flag is set, means in this case 45 message carry flag is set, then what we are doing? We are transferring contents of 2052, means which is M, into A. So move what? Move A comma M. Okay, move A comma M. Now apply loop 3 times. Again I will decrement C by 1, and this is the loop 1 label. Loop 1 colon then DCRs. Okay, if carry flag is reset, it will jump here. It means contents of A is already larger than M. If contents of A is smaller than M, then move contents of M into A. Now J and Z, again I will use loop 2. Okay, J and Z loop 2, and where will come this level? This will come here in INXH, this one INXH. Okay, loop 2 colon and space. Then last step, STA3050. Okay, now what is happening? Just see here. M is 2050. Now contents of C is contains of 2050 means 4. Now C is 3. INX M is 2051. Move A comma M 2051 means 45. A is 45. INX H means M is 2052. Compare M. Now compare 45 and 65. 45 and 65 carry flag is set. So it will not jump in this level. It will execute move A comma M means program will execute in sequence. Move A comma M means contents of A is what? 65. Then J and Z loop 2. Now DCRC. Okay. Now DCRC. Then C is 3. Now decremented by 1 2. J and Z loop 2. Carry flag is 0 flag is not set. It will jump to loop 2 here. Now INXH. Now 2053. Compare M. 65 minus F2. Okay. 65 minus F2, and again carry flag is set. So what will happen? Now contents of A will be F2. Okay, move A comma M F2. Now DCRC 01. Okay, 01. Now again it will jump here. Now INXH. Now this INXH means M is 2054. Now this 2054. Compare M. It will compare F2 and 77. Now F2 minus 77 carry flag is what? Reset. Now it will jump from here to here. Now sorry, here to in loop 1. Now this move A comma M will not execute. DCRC. Now C is 00 and J and Z loop 2. Now 0 flag is set, so it will jump to from here to here. ST3050, and last instruction halt. Okay. Now I will run this program in simulator. Just copy from here. Okay, this is your simulator. This is your program. LXIH 2050 move C comma DCRC this. Okay. Now you can check the result. Okay, how will you check the result? Suppose initial value 2050. Total elements are what? 4. Just write down 4. Set. Okay. What is the value of 201? 45, 65, F2 and 77. 45, 65, F2, 77. Now 2051. 2051. 45. This value is 45. Then 2052. 2052. This value is what? Suppose 55. And 2053. So this value is F2. Then in 2054. 2054. Suppose value is what? 77. 77 set. Okay. Now execute. You can execute whole program in single step. Okay. Now check 01 30. Already it is showing F2. Okay. You F2. Okay. This is your result, and you can see from here largest number is F2. Okay. And suppose you have to determine smallest number. In place of largest number, you have to determine smallest number. What you will do? You will do only this one. Instead of J and C, you will use JC. Okay. Rest of the program will be same. Now I will execute. Just copy from here. Copy. Paste. Okay. This is your program. I already inserted the data. Just check the result. Okay. First execute. Okay, I executed. Now you can see the result 45. Oh, this is the smallest number in an array. How will you determine smallest number in an array? Okay, smallest number is 45. So it is right answer. You can see 45. Okay. Now one more program I will implement. Suppose you have to determine assembly language program to determine square root of a number. SQ square root of a number. Okay, square root of a number means it will be perfect because 8085 deals with 8-bit only, so it will be perfect number. How will you do? How will you perform? How will you implement this program in 8085? Okay, what is the procedure for this? I will explain. Suppose number is 9. Number is 9 in suppose number is 9 and you have to determine square root of this number. What you will do? How it is determined? Okay. First of all, I will decrement this 9 by 1. 9 minus 1. The very first step, 9 minus 1 equal to 3. 9 minus 1 equal to 8. Then next step, 8 minus 3. You have to subtract every time odd number. Okay. First 1, then 3, then 5, then 7. In this way, you will determine the square root of a number. Now 8 minus 3, 5. Then next 5 minus 5, and you will perform this task until you do not get 0. Okay, means total how many steps are used? Total steps used are 3, and you know square root of 9 is nothing, it is 3. Okay, similarly, suppose you are determining square root of 10. Square root of 10 means 16. 10 means in hexadecimal 10 minus 1 means 16 minus 1 F. Then 15 minus 3. 15 minus 3 12. Then 12 minus 5 7. Then 7 minus 7 0. Means total how many steps? Total there are 4 steps. Okay. What you will do? You will subtract 1, 3, 5, 7, 9 and so on. When you will get a 0, and that will be the last step. Okay. Now I will implement this in 8085. Suppose counter MVI. So I am using C register for this. C, 01. Okay. Then one for this 1357. I am using D register. MVI D, comma 01. Then what I am doing, just suppose number is in 2050 memory location, use LDA 2050. Suppose number is in available 2050 and you have to store the result in 3050. Now suppose number is 9, it means contents of A is 9. Now what you will do, you will performing 9 minus 1 means sub D, 9 minus 1, now value of D is 01, so 9 minus 1 it will be 8. Then if 0 flag is set, I will check here, because if number is 1 then only one step is required, 1 minus 1 0, so answer will be C. Okay, so I will use JZ. If 0 flag is set, JZ loop 1. Okay, JZ loop 1, JZ loop 1. Then what I am doing, I am incrementing D register every time by 2. So use INR D, again INR D, because I am adding 2, 1 plus 2 3, 3 plus 2 5, and for every step use INR C. Okay, INR C for this step 1, step 2, step 3. Now after that what is happening, jump, JMP, we have to perform this task repeatedly. Jump loop 2, and this is nothing, this is here, loop 2, this one. Okay, then this, where this loop 1 will come, it will come here. Now where is result? Result is in C register. Move A comma C and STA 3050. Then halt. Okay, again I am repeating, this C is nothing, this is total number of steps. How many steps we are using? This D is nothing, this D is 1 3 5 7 9 so on. Initially value C is 01, D is 0, LDA 2050. Suppose contents is 9. Now sub D means what? A minus D. A is 9, 9 minus 1 8. The first step is performed. Now it will not jump to this loop 1. Where is loop 1? This. Here loop 1 will come. Here. Loop 1. Okay. This loop 1. Suppose I am taking value 1. 1 minus 1 0. So it will directly come here. Move A comma C. C is 01. So it will give 1 answer. In this case 0 flag is not set. 9 minus 1 8. JZ loop 1. It will not jump. It come here. INR D. Now D is 3. Okay, this 3. Then INR C. C is 2. Jump loop 2. Again it will go to loop 2. Sub D. Now 8 minus 3 5. Okay, then again 0 flag is not set, so it will not jump here, it will come here. INR D. Now D is 5. 2 times INR D, D is 5. INR C is 3. Jump loop 2. Now again it will come to loop 2. Sub D. Now last step, 5 minus 5 is 0. Now 0 flag is set, so it will directly jump from here to here. Now C is 3, so A will be 3, STA 3050. Okay, this is your program how to determine square root of a number in 8085. Okay, now I will run this program in simulator. Suppose, okay, number is 2050. Suppose number is 9. Just 9. Okay. What will be the answer? Answer will be what? Sorry, now you will execute. Program is executed successfully. Now answer is 3. Okay, answer is 3. Suppose I am taking another data 10. Okay, 10 means nothing. Sorry, this is memory location 205. Suppose data is 10. 10 means 16. This 10 is in hexadecimal. Now execute. 10 means 16. So answer will be 4. Here it will come 4. Execute as a whole page and answer is 4. Okay, in this way you can implement any loop. It's all about your today lecture. Thank you so much for watching. Have a good time.